data science videos. Today's topic is going to be a bit different. It's called a temperature control lab. This is using a homemade remote control device which is called LSTM controller for temperature forecasting. As you can see on the screen, there is a device which is newly created. This is a normal temperature meter. There is a small heater and a sensor. Now, as you can see, a temperature control lab actually looks like that, and you can build it at a very low cost using a microcontroller. The real temperature meter is a low cost, locally available small device which simply reads the temperature at this place through a thermocouple sensor. This is 16.1 degrees right now. There is a small heater, the yellow one. There is a 100 ohm heater which is connected here, which can be powered at 0 volt or 5 volt or 10 volt. 0 means 0% power, 5 means 50% power, 10 means 100% power. So the idea is that you are going to give a fixed power to on this heater, and temperature will exponentially rise. So as you can see here, 16.1 degree, this device will read this 16.1 as 15.8, slightly less. It is almost close to 16.1. That means the value which is here will be read here. Here you can see it is called, now it is called a process variable PV, and it is also called 15.8%. It is not percent, 15.8 degrees it is. And 0 to 100 degree will correspond to 0 to 100 percentage. Now, coming into the power which is QI here, that means 1% of the power is being fed into this small heater right now, and you can feed 50% or 100% depending on your interest, so that the heater will exponentially rise the temperature and read it. And now all this setup which we are doing is for online temperature forecasting. So that means the objective of the setup is to create a remote device that we are and on heater power and read the current temperature every second from a sensor to create a time series dataset first online. Then this setup will be used to forecast the real-time temperature further. So, it is very difficult to collect temperature from the environment over hours and then predict it and see. So here what you do is you are just heating up a heater and you are getting a profile of the temperature. You would like to see, just after collecting the data, it will run a neural network. Neural network will create, it's called LSTM, and it will create a forecasting model which will be projected then and there, so that you will see how the temperature is further rising, is it according to the projection. So the topics that will be covered in this video is hardware, some idea about the schematic of this device, how to establish a connection, and since I said it's an online device, it is an embedded HTTP server. Through one single HTTP command you can read the temperature and also set the power to the heater. There are two functions done by this. One is reading the temperature, other is set power to the heater. Now the voltage setting is what? Power is nothing but voltage. You have to set the voltage as 50% voltage or 100% voltage. Depending on that, you can use a function to set the voltage, function to set the heater power. Now temperature reading is done through a function. The function is called read latest temperature 10 times and write to master CSV. This is some kind of function name which we have created. You need not give such a long name. You can give simply read temperature and write to CSV. To read temperature, format them and create a time series dataset and also how to write into a CSV file we will be discussing in a master.csv. So the block diagram looks like that. You have a temperature meter with sensor. You can see that this is small temperature sensor and heater here, and this is simple temperature meter, which is very commonly available locally. This gives us 0 to 10 volt to this particular device. This is a microcontroller based device, which we call it LSTM controller or forecast controller or something like that. So what it does is it takes the voltage and converts into again temperature into this device, and device is an interfacing device to the computer. So this temperature can be read from this computer to a Python command. So that means this is an embedded HTTP server running inside. So through one single command in Python you can read the temperature, and through one command you can also set the heater power so that it will heat up the heater. And you can, how this device is created, you can see, you can read it further in the one of my articles which is given here. Now when it comes to embedded HTTP server, which I said which is inside this blue box, it's a what it does actually, it takes the temperature from here, throws it to the PC, and other thing is like it takes the heater power command from here and writes into the heater here, something like that. Now these two functions it does. And now if you look at the device, it's embedded HTTP server, means it runs a small server inside, and you can, the ping is the command used to test that ping 192.168.1.133. if this is the IP of this particular blue box, then you can, from the PC you ping and see that this is connection is established. Once if the connection is established, you can read and write to get the temperature and also the heater power. Now the circuit looks like that. There is an embed LPC 1768 microcontroller, an ARM embed compiler is used for creating the program, which is not explained in this video, but the hardware part is here. This is Ethernet connection, and you can give 0 to 10 volt from a temperature meter, which can be, so that means the temperature value will be stored here every second. And also you can on and off a heater like this. So this is a circuit diagram here. This is that microcontroller again. This is the Ethernet port, and this is the heater. This heater is here, 100 ohm heater, which is powered from this microcontroller device, and microcontroller is commanded over this HTTP server using one command. So HTTP, like read temperature is one function. HTTP a get command for writing into the heater 0.5, that means under 50% power it will write into the device. So as I said earlier, this is the yellow one is the heater, small heater, and this is the thermocouple sensor. This is the temperature meter. The temperature value is read into this first box, and after that the power which you are writing into the heater is in right now 1%, almost zero power is going, and 15.8 degrees being read back, and this display changes every second. Complete program looks like that. To establish HTTP connections and allowing the program to communicate with a specified host or HTTP protocol looks like that. You have to have a library called http.client, and you have to simply use a library type. So HTTP connection means the program utilizes the HTTP client module to establish a connection to a designated host and path for communication. So HTTP command is the advantage, only one single command is there, no need to remember so many things. Like for example, if I say 192.168.1.102 /RPC /port1 /read, this is one single command together. When we give this get command into the microprocessor, it will simply read the temperature value in numbers. See that? And same way, to write a value to the heater, that means you have to on the heater. you have to execute a function for voltage setting function, and you can give 0.5 means it will set 50% of the voltage, 5 volts. So you can see this is a function to set voltage, and here you can give 0.5 for 50%, 1 for 100%, etc. Now temperature reading function is very easy, and writing into master CSV, it is like reads the temperature and performs conversion and formatting and creates a time series dataset of the temperature readings, and that's called the file called master.csv. The data is then written to a CSV file named master.csv. So now the program looks like that. This is a simple array being defined, and you have a continuous function while true, continuous loop. In fact, function to set voltage 1, that means 100%, 10 volt you have applied, heater is put on, wait for 1 second, slit. After that, simply printing set the power to the heater and started this. It's saying now I am going to read, I have to call a function called read latest temperature 10 times and write to master.csv. So it will go on storing the values of temperature continuously and write into an array, and whatever is your temperature you are getting through this device, blue device, is being printed also onto the screen, and you can write into a CSV file using a single command, and you can see this is the temperature. As it increases, you will see the every second reading will be coming on the screen before it is being written into a file. The advantages are real-time monitoring. The program provides real-time temperature monitoring through continuous sensor readings. Heater control dynamically adjusts the heater power based on the calculated voltage, contributing to efficient temperature control. Dataset creation generates a timestamped dataset of temperature readings, facilitating data analysis and trend identification. So the conclusion is the program successfully achieves its objective of real-time temperature monitoring and heater control, demonstrate the practical implementation of HTTP communication, voltage setting and temperature reading in an automated and continuous fashion. The generated dataset in master.csv serves as valuable data for further analysis and decision making for environmental control system. So next videos right now we have created a dataset. Now using this dataset we are going to create a neural network in the next video, and also forecast the temperature and read the temperature along with, so that you see that the temperature, exponentially increasing temperature, is it following exactly according to the projection or forecast you have done. See you in the next videos. Thank you.